Good afternoon. My name is Robert Hauser, and I'm the Executive Officer of the American Philosophical Society. Welcome to this first day of the APS Virtual Symposium, The Promise and Pitfalls of Citizen Science. I'm glad that so many have joined us today. The American Philosophical Society resides in Lenapehoking, the homeland of the Lenape people, whose historical relationships with the land continue to this day. The APS acknowledges with respect their continued presence and perseverance, and it expresses its sincere thanks for the past and ongoing generosity of numerous Indigenous communities and individuals who have offered their guidance, expertise, and opportunities for collaboration. For those of you who are joining us for the first time, the American Philosophical Society was founded by Benjamin Franklin in 1743. The society is a catalyst for the discovery of new knowledge. Election to membership honors those who have made exceptionally significant contributions to science, the arts, and humanities, and public life. The Society promotes research by providing over $1.5 million in research grants and fellowships each year, primarily to younger scholars who need the support the most. Our library and museum collections and research centers serve scholars and visitors from across the globe. Please check our website, www.amphilsoc.org, to learn more about what we do and for news of forthcoming events. I'd like now to turn things over to Patrick Sparrow, librarian of the American Philosophical Society and director of its library and museum. Dr. Sparrow will describe the symposium and introduce our keynote speakers.
Thank you, Bob, and thank you all for tuning in for our first session, our keynote for what promises to be a very exciting week-long discussion about the promise and pitfalls of citizen science. I want to provide a little bit of context for the symposium and for the keynote itself, and also take care of some housekeeping issues to make sure that we all can take full advantage of Zoom and its capabilities and can participate ourselves in the discussion that we hope to have in a few moments. So the conference, The Promise and Pitfalls of Citizen Science, is really inspired by the Society's current exhibition, Dr. Franklin, Citizen Scientist. This exhibition focused on Franklin's scientific contributions and the wider world of 18th century science. And if you haven't yet had a chance to see our virtual tour of this exhibition, I encourage you to check it out online. You can visit our our exhibition online at our website, amphilsoc.org. And if you do the tour, you'll see that one of the central themes of the exhibition was an exploration of science, particularly who had access to it and who could participate in science in the 18th century and who was excluded. And this week's symposium hopes to expand upon that theme by exploring understandings of citizen science over time, by placing historical initiatives in conversations with present-day projects, as well as reflecting on the future needs and opportunities of the movement. This symposium runs all week. Each day we'll host a panel discussion at 1 p.m. and then at 3 p.m. on Tuesday through Friday, we'll showcase a citizen science project. We're also going to host a wrap-up conversation on Friday afternoon, and I hope you all will be able to attend much of the discussions throughout the week. And I cannot wait to get our first conversation started, but first I have to take care of some Zoom housekeeping. As you all know, we're using Zoom this week. You can ask a question at any time by using the Q&A feature at the bottom of your screen. Those questions will go directly to the moderator, in this case, me. I will be able to see them. And then when we turn it over to a Q&A with our panelists, we'll be able to ask our questions that way. So please, at any time, when a question comes to you, please use that Q&A feature, and we'll try to get to as many questions as we can as time permits. We're also have a hashtag on Twitter. The hashtag is SitSciAPS. And you can see that on the screen as well. So please continue the conversation on Twitter and on your social media accounts as well. And finally, we're excited to offer closed captioning. You can see the closed captioning option on the bottom right of your screen. And so now, with that out of the way, I'm excited to turn things over to our keynote discussion, the promise and pitfalls of citizen science. To kick things off, we've invited Professor Caren Cooper, who's been a leader in the citizen science movement for decades. And she's going to reflect on the history of citizen science. If you're unfamiliar with Professor Cooper, she's the Associate Professor of Public Science in the Forestry and Environmental Resources Department at North Carolina State University. She is the author of Citizen Science, How Ordinary People Are Changing the Face of Discovery, and co-author of the Field Guide to Citizen Science, How You Can Contribute to Scientific Research and Make a Difference. She has published over 75 papers across multiple different disciplines, and she was involved in the development of citizen science, of the Citizen Science Campus Program. She was also instrumental in forming the Citizen Science Association and has served on a number of various boards and advisory groups, including serving as Director of Research Partnerships for SciStarter.org, an online connector of several thousand citizen science projects. She's going to speak for about 15 minutes or so, and then Dr. Arthur Kaplan is going to join us to talk about citizen science and ethics in the age of COVID. Dr. Caplan is the Drs. William F. and Virginia Connolly Mitty Professor and founding head of the Division of Medical Ethics at NYU's School of Medicine in New York City. Prior to NYU, he was a professor at the University of Pennsylvania, where he created the Center for Bioethics and the Department of Medical Ethics. He has served on a number of different boards and advisory groups. Most recently, during the COVID-19 pandemic, he co-directs an advisory group on sports and recreation for the U.S. Conference of Mayors, created a working group on coronavirus vaccine challenge studies, developed an ethical framework for distributing drugs and vaccines for Johnson & Johnson, helped develop rationing policies for NYU's Medical Center and many other health systems. He's a member of the WHO Advisory Committee on COVID, Ethics and Experimental Drugs and Vaccines, and he helped, he was an advisor for Moderna. And he also serves in the NCAA Sports and COVID Committee, quite a lot. And I can't wait to hear him talk about COVID and citizen science today. So with that, I want to turn it over to Professor Cooper.
Great. Thank you so much for having me here. Let me get I have some slides I'm going to share. Let me get those started. Yeah, thanks. It's really great not to see everyone, but to know that you're here. And the theme today, is the promises and pitfalls of citizen science. And I am going to focus on history a bit. And what I want to do is really challenge you to connect the dots of history to the present day and to how we envision the future of citizen science. And what I hope is that you'll see that the history of the United States, including the history of colonization, the history of slavery, the history of the structures of our Western scientific enterprise and of our environmental movements, that all of these really have a legacy of inequities. And those inequities, I think, really shape the fundamental promises and pitfalls of contemporary citizen science. And when we look at citizen science today, it is a profession, right? And it's kind of funny because it's a profession of working with non-professionals. But we can see it as a profession in these emerging and budding professional associations of citizen science practitioners and scholars that have really emerged over very recent years. What I would like to do to kick things off for this conference is to review kind of like the last 200 years that have led to the professionalization of this field. But lucky you, I have 15 minutes. So what I'm going to do is I'm going to draw on a couple of Victorian era kinds of citizen science examples and call out some of the factors and legacies that are responsible for where I see some of the major pitfalls and promises in citizen science today. So first, just for some context, I just want to note that there's a lot of different cultural and disciplinary and scholarly kind of traditions under this umbrella of participatory sciences. And I think, for example, I think Arthur is going to speak more about maybe what's over here in the DIY biohacking community lab sort of end of things. There's a lot of different terms and names. Some of these I have here are acronyms like volunteer geographic information systems, community-based participatory research, community engaged research, community owned and managed research, as well as crowdsourcing, distributed computing. There's a lot of different terms, and this is like a tiny fraction of really the variety of participatory approaches to science that are out there. What I want to do is focus really on the history of two groupings related to the environment. And what I hope is that you'll see with these strands, and they're sort of like their own mini umbrella terms, of citizen science and community science. And I think that we'll see that these kinds of practices can either reinforce or challenge sort of the institutionalized scientific enterprise. So citizen science, what I'm referring to there is fairly top down. It's run by individuals who are at institutions, whether it's government institutions, universities, NGOs, museums, what have you. It's institutions. And the goal there is the same as institutional science, which is the goal of science, which is to create generalizable knowledge, right? It's discoveries for the benefit of society. And if you can't see me, but I'm putting society in air quotes there just to say that it's kind of under this assumption that we have a society where that has distributional equality, right? Where the benefits and burdens are all equal across different types of people, which we don't really have, which is why we have community science. So community science is very bottom up. It's run by individuals, not at institutions, but in communities. And the goal is really to fix problems where people live. So it's discovery for the benefit of society, but for segments of society that are not receiving the benefits from our institutional science. And the scholarly traditions from these two sort of strands of participatory science are really quite different. Citizen science, and in this, like I'm talking about like organized efforts of monitoring birds or butterflies or bees or those kinds of things, the weather, that kind of stuff, has really its traditions under volunteering in service to something. And in this context, it's volunteering in service to science. And that's just in contrast to community science, which really has these scholarly traditions that stem from Paulo Freire, who wrote The Pedagogy of the Oppressed, which is really about engaging academics sort of in liberation resistance movements, in emancipatory kinds of philosophies that he espoused. And so in this case, community science is about empowerment by engaging in science and by co-creating knowledge, being able to make and advance legitimate knowledge claims. And both of these kind of strands struggle in different ways to be visible paths for people who are not scientists to advance those kind of claims. So I'm going to start with a little history on citizen science, then a little bit on community science, and circle back around to citizen science. And so I'm going back in time a bit to the Victorian era, really because even though it was centuries of leading up to sort of the professionalization of Western scientific enterprise, I kind of see it as culminating in the Victorian era, because that's when the term scientist was coined and a lot of the professionalization happened. And I think you have to have the profession of science in order to have sort of its opposite, citizen science. And so I like this quote from Mark Twain, which just says, what is joy without sorrow? What is success without failure? What's a win without a loss? What's health without illness? You have to experience each if you are to appreciate the other. And so in the Victorian era, the hierarchical boundaries that really set and delineated modern professional science really was then able to simultaneously define its antithesis, which is the amateur science, right? If you have professionals, you can have amateurs. And these activities of amateurs have continued since in organized fashions in so many different forms under that umbrella of participatory sciences. So I'm going to start with a key player, and maybe as philosophers, you all have read this book, really great book by Laura Snyder called The Philosophical Breakfast Club, about these four scholars who really changed and established modern science. And I'm going to focus on the one sitting in the, his portrait is sitting in the chair, which is William Hewell. And he was actually the go-to guy for jargon, scientific jargon, and he did coin the term scientist, although it took a while for it to catch on. And I think it was partly because philosophers were saying, hey, stop calling yourself philosophers. And he was saying, hey, you people that tinker with things and build things, stop saying you're what we are. So they were sort of the artisans, became the engineers, the makers. Anyway, what he said was, as an artist is a musician, a painter, or a poet, a scientist is a mathematician, physicist, or a naturalist, right? And because there's all these specializations occurring and disciplines forming. And so he made this umbrella term of scientist to encompass that. But what this group really did together was a lot of things, but one of them was actually to make science more egalitarian. You might say, oh, in what ways did they make it more egalitarian? Was it with gender? No. Race? No. It's actually with wealth. So in the past, it was really science could be carried out by those who had wealth, right? Men of leisure who had wealth, or maybe had a patron who was wealthy, right? So here's from days prior of Galileo presenting gifts to his patron. And the gift in this case was the discovery of moons around Saturn or Jupiter, moons of Jupiter. Anyway, and so what really was the transformation there was for government and other entities to pay for science. And yeah, so that was the transformation. So then any educated white man could be a scientist. Open those doors up. Okay, so what's interesting though is that with William Hewell, is that what he did really and was so convincing was actually citizen science that advanced the imperial causes of the British government, because he was very interested in the study of the tides. And so was the Royal Navy, because they would love to know the tides everywhere. So with the help of the Royal Navy, William Hewell created what was called the Great Tide Experiment. And he was the scientist of this, and everyone else he called subordinate laborers. So you talk about contested terms. And he did this in 1835, was when this experiment took place. He had people positioned at 650 different stations on both sides of the Atlantic, recording the height of the tide. And they did this every 15 minutes, day and night, for 2 weeks straight, at the exact same moments. So that's like, I mean, that is, yay, Royal Navy, because it's an incredible feat to organize before smartphones, before telephones, and before computers, because that basically resulted in hundreds of thousands of observations that he had to process before electronic computers. He had men who were computers. He won a Royal Medal for this work. And advanced our understanding of tides, right? He wanted to draw these co-tidal lines. He thought, if it was low tide on one side of the Atlantic, presumably it would be high tide on the other side. And this kind of work with tides is restarting with modern citizen science. There's a lot of the coastal states, Hawaii, California, Florida, have these king tide projects. It's very kind of iconic citizen science. You use a smartphone, you snap a picture, and it's showing the king tides are the high tides. So they're kind of a precursor to what our regular tides are going to look like as climate change is causing sea level rise. So just to transition from this for a moment, so what was happening in the US in 1835 when this transformation in science was happening? And the US was very much still a frontier for colonizers. It was still a place of slavery for many. And when we look at history and this sort of manifest destiny and the colonization in the US, and what we're left with, which is sort of settler colonialism, which is sort of the legacy of that effect, has greatly informed the environmental movements within the United States. And so, for example, the establishment of our national parks involved the removal of indigenous people from those lands. And this idea of nature being, and pristine nature being devoid of people and being separate from people has been a big cornerstone of a lot of mainstream environmentalism. That nature is not where we are, it's out there, and it's to be protected, and it's to be protected from humans. And I would say that institutions and scientific institutions have really have done research that supports the agenda of mainstream environmentalism with ecology research, conservation biology research, and that kind of thing. And citizen science has really aligned with those institutions in supporting mainstream environmental movements. And as Dorcetta Taylor has pointed out, she's a professor at the University of Michigan. And what I described is in several of her books, and including this somewhat new report that she has about the state of diversity in environmental organizations, just really shows how separate or how sort of white and affluent the environmental movement is. Even up into the 60s, people were, making big stinky resignations over the admission of Black people and also Jewish people into organizations like the Sierra Club. As she says here in 1972, there was a vote on should the club concern itself with the conservation problems of special groups as the urban poor and ethnic minorities, and most members voted no. Right? Even though it's all one earth, one environment, as this environmental justice activist said, the people who hug trees don't usually hug people. So there's sort of a lack of addressing the issues of certain segments of the population. And so if we look at colonialism and how it's influenced the environmental movement, we can look at slavery and the legacy of slavery as how it influenced the environmental justice movement. And so after 400 years and it finally being brought to an end, followed by Jim Crow laws, redlining, segregation, that even today, like as you can see on the map on the right, there's still a legacy of segregation in the US. In neighborhoods, in cities, it's at all spatial scales, even at our continental scale. The blue shades are showing basically populations of descendants of slaves, and which is much higher still in the former slave states. And so when you have segregation by race, what that really means is that there has been desperate, what am I trying to say, unequal distribution of the burdens and the benefits of different environmental features. So in particular, it's known that environmental burdens are disproportionately affecting people of color because of this kind of segregation. And that has really informed the environmental justice movement. And because the mainstream movement and the institutions that support it have very clearly not been addressing all of the benefits to all the members of society, community science has really been a predominant force in assisting environmental justice movements. sort of, Van Jones summed it up with the environmental movement, saying we essentially have a racially segregated environmental movement. We're just too polite to say that. So we often say we have an environmental justice movement and a mainstream movement, but it's really one environment, right? We have one planet. And so I think the same falls true for the participatory sciences, in that it's racially segregated in many ways, because citizen science, which is very connected with institutions, does tend to have participants who are white and affluent and highly educated, and supporting, it tends to align very much with mainstream environmental movement. Whereas community science tends to be very diverse and supporting of the environmental justice agenda. And so where does that leave us in terms of the promises and pitfalls? So I guess what I would say is that it means that citizen science and the institutions that it's associated with could really do a better job of serving all segments of society. And so just to go through a couple of examples, this is an iconic project here on the left, which is showing seasonal migration of barn swallows. This is from eBird at the Cornell Lab of Ornithology. Tens of thousands of people participate and share bird observations. And we know so much. It's amazing the detail with which we can model the distribution of birds. Now imagine if we could do the same for modeling the distribution of air pollution. This is just a map from the World Air Quality, showing the World Air Quality Index from sensors, from government sensors. But there's more and more low-cost, affordable sensors out there to add to and to build this network and to understand other aspects of our environment. Anyway, I just wanted to point out that none of that is really new. eBird can make animated maps and whatnot, but that same kind of idea has been around also since the Victorian era. So a contemporary, this is a map, a chart from the 1851 from Matthew Fontaine Maury. Maury was in the Navy, and this map shows the seasonal movements of right whales and sperm whales. Actually, you can read about it. It's a footnote in Moby Dick, although it was this real world project to crowdsource these observations. But what I want to point out that Maury did from this institution, from the Navy, was actually distribute specialized logbooks for sailors to record the wind and the currents. He viewed each ship as a temple of science sailing on the ocean, right? And he had contributors from 13 different countries. Some of these countries were at war with each other. This was from people in the navies and merchant mariners. And from this, he was able to distribute these charts to everyone, and it really made sailing safer and faster for everyone. And he's considered the father of oceanography. His program persisted. I'll say, as this one quote said, as one participant had said, until I had taken up your work, I had been traversing the ocean blindfolded. And that's what science does, right? And there's some frontiers that we can't get to by regular science alone. It takes this kind of pooling together of observations to be able to see what we could not see before. And this program actually, it took a hiatus during the Civil War, but it continues to this day. It's actually part of an agency now. He's also considered the father of tradecraft, which is spying. I don't know. But anyway, but I find a lot of hope in his version of citizen science. And so I just wanted to compare these two Victorian era men and the projects that they did with institutions, but that I see as being really different and that highlight the pitfalls and the promises. So I think what Hewell had done kind of illustrates some of the pitfalls of highly hierarchical citizen science, of having people contribute to sort of an elite, of the privilege of contributing as volunteers to an elite program, even like Tom Sawyer, even paying to do the work. And there are citizen science projects where you have to pay to do the work. And contrasting that with the story I would ascribe to it is one of the versions of Stone Soup, which is where everyone comes together, contributes what they have. In Stone Soup, they contribute whatever vegetables they have, and then collectively and together, can make this delicious soup that feeds the entire village. And so I hope that that historical perspective can challenge you to see that the most imperative pitfalls really involve these racial disparities within the participatory sciences, but it's because they highlight that the scientific benefits that come from institutions are not equally distributed across society. And so the biggest promises that we can have is how we go about fixing it, in as much as citizen science can transform not only itself, but also professional science into being a more egalitarian practice so that the fruits of science reach all segments of society. Thank you for your time. I will stop sharing there.
Hello, everybody. Can you hear me, Adriana?
Yes, we can hear
Very
you.
good. And I think you can see my slides?
Not yet.
Not yet. Let's see what I can do about that. How
There you
about
go. Yep.
that? All right. So thank you for having me. And thank you, Caren. That was a really interesting presentation about the emergence of citizen science and its disparities in terms of communities involved, but just impressive as to what can be done in many areas of naturalism and observation with large groups of people, both 100 years ago and right down to today with monitoring birds and potentially pollution and many other things. And I want to say, even though I'm going to be talking about a sort of citizen science experiment that I am not happy with and think had many pitfalls, it may be a subcategory of citizen science that we have to keep a special eye on because it's interventionist, and that is the development of do-it-yourself vaccines. But nonetheless, I'm a big supporter of citizen science. And one reason is, having spent a lot of time in the current debate during the past year about COVID, watching many citizens in the United States not understand anything about science or how it works, or watching leaders disparage science and not understand much about how it works. I think the citizen science movement generally might help be a counterweight to that kind of ignorance or that kind of manipulation. And I think that citizen science could also alert people to the need to pay attention to problems that their politicians may be ignoring, such as infrastructure problems like we're seeing in Florida right now, where a dam full of wastewater is at risk of breaking and flooding Tampa Bay. These kinds of reports on bridges or infrastructure might be very, very useful to draw attention to needs that politicians tend to put off. I'll also say I'm a fan of citizen science before I tell you about a cautionary note, because one of my real heroes is Ben Franklin. One of the awards that I got in my career that I'm very proud of is the Franklin Award from the city of Philadelphia. I'm thrilled that this symposium is taking place in his honor. And so that's a great role model to follow and think about in terms of watching someone integrate many areas of expertise into an amazing career. So I'm going to talk to you for the next few minutes about the danger of do-it-yourself vaccines, a form of citizen science, sometimes referred to as biohacking, as Caren said, meaning people who just take organisms and try and modify them in various ways outside the usual confines of scientific laboratories, and outside the environment of containment that usually prevails when you're doing, say, genetic engineering or dealing with microbes that might easily escape. But the case of the do-it-yourself vaccines that I'm going to talk about really involves a mix of scientists and non-scientists. It's a little bit like the Hewell model that we heard about from Caren, where scientific leaders engage laborers and helpers, people they see as assisting them to try and advance an idea about how to vaccinate against the SARS-2 COVID virus. I do have a little declaration to make about disclosure and conflict of interest. We bioethicists spend so much time yammering about conflict of interest. I'm even going to mention it in my talk that I feel some obligation to show you things that I have been doing over the past year that might potentially generate some conflicts, although I'm pretty comfortable that they don't for anything having to do with this talk. So the case that I'm interested in took place last summer, and it involved a collaboration between an entrepreneur, not really a scientist per se, although with a wonderful scientific background, but someone who is more in the business side, Preston Estep, and about 20 other people initially, including George Church from Harvard, who is one of the world's outstanding geneticists and certainly a giant in the field of precision medicine and genomics, synthetic biology, just an amazing scientist. I consider him a friend of mine, even though he and I fight and battle over many things, but he's really a brilliant fellow. So these two very competent, esteemed, brilliant people believed that they had enough information about the path of the coronavirus into the body and decided to try and develop a vaccine involving a nasal inhaler and injecting something into the cells in the nose that would intercept and block the COVID virus. Their goal was to develop a simple recipe, something that was easy to use and administer and be perhaps low cost, engage the public in trying it out, both other colleagues of theirs who were scientists, some of them, some not, and then share it potentially with the public. And so they didn't really want to wait for people to run big, long studies on vaccine trials. They felt they had to go faster. And one way to do this was to develop an initial core group of people who were interested in testing the vaccine upon themselves. So they created the Rapid Deployment Vaccine Collaborative, or RADVAC, engineers, scientists, researchers, some affiliated with MIT and Harvard, also ordinary citizens, friends of theirs, who would be in the group and agree to try and test out this homebrew vaccine. So they developed this nasal spray coronavirus vaccine. It wasn't an injection, as I said, had certain peptides, which they thought would trigger the creation of antibodies to the SARS-CoV-2 virus. They felt that the virus was most likely to get into you through breathing through your nose. By the way, that is very ironic because, as many of you know, when we were promoting mask behavior about the same time last year, and really starting to urge people to wear masks, many people did not wear them over their noses. On the other hand, we also know that there are pathways for this virus to get into us that involve the eyes and certainly the mouth. But nonetheless, they thought the virus first takes hold often by getting inhaled through the nose, and that is why this injection might be useful in tamping down COVID. And the idea was to test it on themselves and the members of this little group, which they would recruit and stay in touch with basically by the internet. So we wrote a paper, a colleague of mine, Allison Bateman House, and myself in Science, shortly after this citizen science experiment became public, basically saying we were really worried about what was going on here. And our main worries were that there is an enormous amount of distrust on the part of the public. There was then, back at this time period of summer 2020, And there has long been distrust on the part of the public in vaccines, even when they go through randomized clinical trials with large numbers for many years, including both animal studies and human studies. There are many, many people who hate vaccines, distrust vaccines, stir up hesitancy and doubt about vaccines. And we were concerned that RADVAC and the self-experimentation idea might, in fact, reinforce distrust if a group of amateur people are outside the usual pathway for vaccine development, meaning going to clinical trials in humans. And by the way, for those of you who don't know, the usual steps are lab studies, animal studies, experiments in humans, healthy volunteers, phase 1, experiments at different doses in humans, and also monitoring for biological activity, phase 2, a couple hundred people, phase 3 in a vaccine trial, tens of thousands of people, randomized, placebo-controlled, vaccine versus nothing. And you study them for as long as it takes to get enough people naturally infected by whatever it is you're trying to protect against, say flu or COVID or measles or whatever it is, to get significant results. And that usually takes a couple of years. So this looks like a big shortcut. And in part, I think the people in RADVAC would have said that's exactly right. We do want a shortcut. It's taking too long to go through that FDA process in the middle of a plague. But we were concerned that there already was a lot of talk by the Trump administration at that time about warp speed in developing vaccines, and that had seeded doubt on the part of many about whether vaccines could be trusted. So talking about going very fast made a lot of people think you were cutting corners. We were concerned that polls were showing in the summer of 2020, as many as 50% of people polled in the US and the UK said they wouldn't take a vaccine. Now, those numbers are a little better in both places. And as you know, if you follow the rollout of various vaccines today, there's still an enormous amount of resistance to taking vaccines in many communities. 49% of Republican men in a recent poll said they wouldn't take a vaccine. 30% of Massachusetts state police in the past month refused a vaccine. There are many in the African American and minority communities who distrust vaccination, say they won't take a vaccine, even though all of these groups have many people who might be at high risk. So distrust is a huge, huge problem. So if you're seen as cutting corners, if you're seen as doing something, if you will, rogue or renegade or outside the beaten track, that could make matters worse for trust. So we felt worried that RADVAC's do-it-yourself vaccine movement in this small group of citizen scientists and professional scientists might add to the already existing skepticism that was being caused by claims made by politicians, where some would say vaccines are going to be here very, very fast. You remember in the summer of 2020, Donald Trump was pushing hard to say that vaccines would be there before the election took place, and was hugely disappointed that didn't happen, to the point where he never mentioned vaccines again after the election until the time when he left office. But many politicians were, if you will, stirring skepticism about vaccines, sometimes unintentionally, sometimes when they said things like, we're going to try and influence the FDA to give approval of vaccines before the data shows that they're ready. And there was a perceived lack of independence on the part of government agencies from political pressure to approve vaccines. That was a big worry in polls as well. And people also, I'm pleased to say, some of the mainstream manufacturers stood up and said, we're not going to put anything out there, no matter what the president says or politicians say or anybody says, until the science justifies it. And we did get a stance from the then FDA commissioner and people working within the FDA, like Peter Marks, that said, we'll quit if there's any approval of a vaccine due to political pressure. Now, ironically, as I think most of you know, the mainstream processes of oversight and regulation trying to ensure safety and efficacy did get sped up in terms of getting vaccines out quickly. We had something occur called emergency use authorization, which basically said independent data safety and monitoring committees recommend to the FDA that we give early approval to a number of vaccines because the data is so strong that they are safe and effective, and the need for them is so great. And so that's how Pfizer, Moderna got approval in December and were being rolled out beginning in January and are still being rolled out today. I comment on that because part of the rationale for RADVAC was things were too slow, but in fact, the mainstream science under professional control, and more importantly, under the control of scientists and science regulatory agencies, delivered with speed, not maybe warp speed in terms of cutting corners, but did a good job. I have to mention again financial conflict of interest of those developing vaccines, because that also was a big issue in critics who tried to sow distrust of vaccines. We didn't really hear a lot about what the financial conflicts of interest might be of those involved in the citizen science. If they got something, would they patent it? Would they sell it? What was driving their formula that they came up with for the inhaler? But ironically, the mainstream science companies involved, pharma companies involved in making vaccine, had plenty to say about the fact that they had no conflict because they'd all signed contracts with the US government and other governments to pre-order supplies, and therefore they didn't need to take the risk in terms of worrying about price, in terms of worrying about profit. They were already paid. So their conflict actually was minimized, whereas the RADVAC group, I'm not saying they had conflict, I'm just saying it was unknown. So vaccine distrust in a public health emergency in terms of using vaccine to work your way out of a plague is hugely dangerous. I'm going to say rogue scientists or people who look like they're operating at the fringe of what is ethically acceptable in developing vaccines would not be changing the minds of vaccine skeptics and those who are hesitant, and might make things worse because people would say they didn't follow any of the steps that normally are followed to get a vaccine through. They're not taking things in through the FDA. They're not taking things in through independent assessment by peer review or data safety and monitoring committees. It's a little bit more of a testimonial model, and that could pose big trouble overall for support of vaccination. Moreover, there's still, when it comes to do-it-yourself work in this area of vaccination, potential harm because you're not doing the animal studies beforehand. They jumped kind of right to humans, believing in what they had. We didn't see safety studies done on healthy volunteers. We didn't see dosage studies. Indeed, some scientists were worried that if you introduce something that might block some forms of the virus, it might encourage the spread of variants, which we're worrying about today with mutations and variants, because it didn't block everything, allowing other strains of virus to get a foothold and grow more quickly. That was a problem then, remains a problem now, but the established vaccines hopefully had a stronger and more powerful footprint against all forms of COVID virus. So I think, again, in the do-it-yourself area, when you're doing something like vaccines, you need external oversight to make sure that the people you recruit know what they're doing. Friends and fellow citizens who say, I'm going to volunteer, that's great, but you still want to make sure they know what they're getting into, what the dangers might be. If somebody got hurt in this citizen science area, there's no plan for compensation or helping them if something did go wrong. And you've got conflict of interest if you're developing your own made in the basement vaccine, so to speak, when you have the very people developing the vaccine trying to recruit friends and others to try it. It's not a very independent approach to recruitment into what is basically research. So I think the best route in vaccines is peer-reviewed science, transparently assessed in carefully controlled trials by independent experts. it's the only way I think you can cement trust during this pandemic or future pandemics. It basically seems to me this is not a place for citizen science, not when the trust in vaccination is so weak and so tenuous. It does seem to me that the idea of people supporting something that is made in this way or touted in this way or advanced in this way could harm not only trust in whatever came out of that process, but trust overall in vaccination. Thank you.
Well, thank you both for this wonderful perspective on the past, the present, and even some ideas about the future of citizen science. And before we got to any questions, and I want to remind everybody to ask questions using the Q&A feature on Zoom, I wanted to ask Caren to maybe respond to what she heard from Arthur, if she had any thoughts. And I also wanted to prompt Arthur to maybe speak a little bit more in reaction to Caren's presentation.
Yeah, I mean, yeah, it was fascinating. A lot of new information for me, because that area of vaccine development and yeah, the different, yeah, just anyway, it was all very new to me, and I enjoyed hearing about it. Um, and I mean, I guess for me too, it just illustrates like what a large umbrella it is of participatory sciences and how different the different forms that it can really take, and that what it means and the different challenges really that exist across that huge spectrum.
Let me add one other example, which I didn't get into. There's a very rich entrepreneur who decided to support a herpes vaccine on his own and recruited some scientists to work with him on this herpes vaccine outside the FDA framework, moved to a Caribbean island and recruited rich people to come there and test the herpes vaccine. Well, this whole thing ultimately got shut down because one of the people that was involved was a scientist, I believe somewhere in Indiana or Illinois, who had not approved it with an IRB, the institutional review board you usually need for human subjects. But the idea of doing a do-it-yourself vaccine and administering it in hotel rooms in the Caribbean for a fee to rich people is way out at the far end of citizen science, no doubt about it. But it's an area, I start to think to myself, it's great to have people watching the whales and sitting at their computers monitoring for signals from foreign alien civilizations. I think all that's fine. But when citizen science moves into the medical, biological, even nutritional side, it may be more fraught, ethically fraught, because you're intervening, you're trying experiments. And we did set up a whole system to regulate, which a lot of this stuff tries to circumvent.
Well, I don't know if you're familiar with Patients Like Me, which is a citizen science platform for to try to help because there are going to be people that are going to want to do, if they have the means, to do whatever kind of testing. So they at least try to make sure that it's done in standardized ways to get the most benefit from it. And I think part of where they saw that was with people who were suffering from ALS, who had, who were terminal, looking for trying any kind of tests, organizing themselves, because people can organize, through social media, through whatever other virtual networks. And so anyway, I think Patients Like Me is a good example of trying to provide the infrastructure to help make it, given that it's going to happen, to help make it at least be as ethical as possible.
Yeah, it's interesting. Sorry, I'll say this and then I'll shut up. I think there are many patient groups who are interested in trying to talk to one another, interested in trying to test things as quickly as they can be, particularly people with terrible diseases like ALS, terminal cancer. They don't necessarily want to find out that nothing can be tested on them because the trial's full, which happens, or they're not recruiting any more subjects because they had an application into the FDA, so they don't want to do it anymore. What I'm saying is we've got to come up with models for oversight and regulation there. Even though somebody's got a terrible disease, you can kill them faster, make them sicker if you're not watching what you're doing. And particularly if it's done by quacks and nuts and kooks who also recruit people. Stem cells is a good area to think about here for those of you who don't know. You go online, you can find clinics offering to recruit people to stem cell treatment for anything: baldness, tooth decay, cancer, you name it. You might say it's a form of citizen choice or citizen participation, but it's also got exploitation. So we got to figure out some way to carve a path here between, hey, let's all get online and share data that's standardized, which sounds good to me, versus, I'm a kook and I'm going to expose you to a lot of zinc, and this will be a great way to find a cure for whatever ails you.
That's great. We have a lot of questions are starting to come in now. Let me just start with the first one that did come in, and it's from somebody watching in India. And the question is about Alexander von Humboldt, the 19th century scientist. Was he a citizen scientist of his time? Could he be considered that? And it gets kind of at the history of when we can start describing somebody as a citizen scientist. Of course, our exhibition calls Dr. Franklin a citizen scientist, and I think you could argue he was, but it's a concept that was probably foreign to him at the time. It just was the way it was. So I don't know, Caren, if you could talk a little bit more about how to think about citizen science historically as a concept.
Yeah. I mean, I think that, I think in many ways you could just see him as a precursor of professional scientist more than a citizen scientist. It blends, like I was saying before, there's a profession. What are you? And so, I think, and same with, with a lot of historical figures. I think we like this notion of citizen scientist as, just to convey this idea that that anybody can make discoveries, that it doesn't necessarily require certain types of professional training. But I think that I don't know what did I say here, that in today's world, I don't know, when I use the term citizen scientist, I'm using it part of this umbrella as really different from a professional scientist. It's like when someone who's pursuing science on their own, there's only a certain amount of things that can be discovered working on our own, right? There's so many things that we do not know. And where I see citizen science coming into play is sort of with that crowdsourcing of observations of a lot of people contributing locally the little bit that they know, which is different from doing all of science. So I don't know, I guess maybe I don't know enough about all of Alexander von Humboldt's contributions, but I would say that I would probably call him more of a professional scientist or precursor to that than a citizen scientist.
Great. Thank you. So two questions from Bob Hauser, one of which is for Dr. Kaplan and the others for Professor Cooper. So Arthur, Bob wants to know what happened to the do-it-yourself vaccine. What's the story?
Well, radio silence. We don't know, but I have a feeling the approval of Moderna, Pfizer, Johnson & Johnson, and AstraZeneca in Europe and elsewhere sort of took the steam out of the idea that we were going to go too slowly in getting vaccines done. The system of professional science, amazingly, showed itself capable of really going faster. I don't want to use warp speed because it still freaks people out, but faster, not bending standards, but getting data collected in a more rapid manner and getting it analyzed independently. So that's something that I think will live with us post-COVID, interestingly enough. But I do think the appearance of the vaccines, I'm guessing, but I think it sort of obliterated the need for the intranasal one. Great.
Thanks. And Professor Cooper, Bob's question for you has to do with the ways in which citizen science is sponsored. In your talk, you talked a lot about how it's often institutionally sponsored or driven. And he was wondering if you could talk a little bit more about initiatives that maybe are completely citizen-led, that lack that type of institutional sponsor. And I'll maybe ask a follow-up, but I'll let you answer that first.
Yeah. I mean, there's definitely still a role for individuals who don't have all the scientific credential training, like credentials behind their name, to be contributing to science. And I do see that in ecology, in the natural sciences field, natural history fields, people who are publishing papers even about birds, about butterflies and whatnot, who don't have all, who are not PhDs in science. They develop that expertise and they contribute to knowledge production. If that's what you're asking about. But I was kind of saying that about citizen science and its link to institutions as the way to be able to make those valid knowledge claims, and in contrast to community-driven science, which happens very much independent of institutions. But yeah, I do think there's definitely a role for individuals contributing on their own. But it will encounter these issues of, I mean, these professional scientific, I don't want to say gatekeepers, but like these institutions, or sort of the institutionalization and professionalization was established as a means to create, as to valid ways of generating new knowledge. And so these aspects of participatory sciences are ways to open that up for individuals without those credentials. And it can look many, many different ways. And people contributing on their own is certainly one of those.
Yeah, I've been thinking about Dr. Kaplan's comment earlier about how he's fully in support of, all the citizen science movements that are, dealing with possible communications from outer space and, documenting birds and all the other great, and I couldn't help, Dr. Kaplan, if I could play a little bit of a contrarian, but you were concerned about the ways it may be in the medical field. And I couldn't help but wonder if perhaps your perspective is influenced by the fact that you are in the medical field and not in astronomy or in ornithology. And so I wondered, if, institutional sponsorship actually is really important for citizen science, or if it does get in the way, and how, in Dr. Kaplan's case, having something run by NYU would probably have greater credibility than, this rich person who's trying to come up with a vaccine and going in the Caribbean and doing stuff. So I don't know, Dr. Kaplan, if you want to respond to that take.
Yeah, that's a great question. And I have a feeling some of what we see dominating some parts of citizen science, as Caren presented it, really is expanding natural history, observational, mass involvement to get input that would be very tough to get in other ways, but not interventionist. It's not like the citizen scientists are going out and saying, I'm going to introduce this new genetically engineered fly onto this island, and I don't really care what the regulations are, and I don't really care what the risks are. I bred it in my basement, and I think I'll do a release to see if I can get rid of malaria or dengue or something, which in theory could be citizen science, but would make me very, very nervous. So I guess I'll put it this way. I don't think it's just institutional territorialism. It isn't just saying we know how to do it, you better not enter. It's that we do have a system for intervention for health, and probably for things that might impact the environment, like I'm going to introduce new chemicals or new seeds or genetically engineered organisms. I'm not sure we'd be applauding citizen science so loudly at that end of the spectrum.
So I have several other questions are really now coming in pretty quickly. One attendee wondered if either of you have any opinions or reactions to the NIH initiative, All of Us, which is seeking, they note unsuccessfully so far, to recruit 1 million Americans to contribute their biological characteristics to develop precision medicine.
Well, I know the project and I support it. However, it really reflects the distrust issue about science more generally that really has beset America. You see it in many, many areas of our science discussions in the COVID related area. All of us is supposed to try and get a better database for precision medicine. A lot of genetic variability in the United States. Most of the studies tend to be done still on white males. Don't really involve pregnant women, don't really involve women as much, certainly don't involve minorities as much. So the idea is, let's do a sustained push to recruit a real database of diverse genotypes. They're having a hard time getting there. So it confirms my belief in three things. One, citizen science projects of the sort that Caren talked about that are way over in the observational side, great. Let's get more people involved in them and get them involved early when they're in junior high or high school, and let them start to think about science and work around scientists and with scientists. Two, distrust is big. Distrust of professional science is just a real problem that we've got to take on. And three, do-it-yourself science when it comes to things that people perceive might hurt them. Who's going to know my medical history? Who's going to have my genetic information? That's a super sensitive area that's different.
Well,
Mr. Cooper?
yeah. I think that, so right now, All of Us says that their program has three sort of areas to it, and one is genetics, one is lifestyle, right? Like you can measure with Fitbits, like activity and stuff like that. And the third is environment. But in practice, it seems like a heavy focus on genetics, a little bit on lifestyle, and very, very little on environment. And genetics and lifestyle are like saying like your health is totally like from your genes or from your lifestyle, whereas what we know from the environmental justice movement and that research is that one of the biggest predictors of health is not your genetic code, but your zip code, right? And where you live, and that your environment actually is a huge influence on health. And so I think if All of Us wants to do more or be more successful in recruiting diverse people to that program, that they're going to have to beef up the environment part and that area of research.
Great. So another question that I think is great for both of you is coming from Kevin Madger. And he is looking at citizen science and water quality monitoring. And he notes that in his experience, he's encountered pushback from regulatory agencies who don't want to use the data that citizens are collecting, perhaps because there is a lack of trust the other way in citizens doing science for themselves. I don't know if you wanted to comment, Professor Cooper, on this, on how citizen science can work effectively with government, and also Dr. Caplan, if you just want to respond about the kind of ethics. You talked a lot about having good data. How can you ensure that you have good data that regulatory agencies can trust?
So I don't know the water, like the stream water quality monitoring world all that well, but I know that in some states, I think it might vary from state to state, because I think some states really have great partnerships with water quality monitoring volunteers and do use those data to declare different streams to have different impairments and to set them up for remediation. But I can imagine that it's not the case universally. And I think with air monitoring too, it's a long sort of struggle to incorporate different types of standards and data quality from different types of instrumentation to be relevant for air quality regulation. So there's a lot of work to be. I hope it is changing, but there's definitely a lot of work to be done in that regard.
Well, just very quickly, I'll add to say, standardization and harmonization are huge issues on the professional science side with respect to data registries. We have a lot of different groups studying genetic precision medicine in relatively small groups, but they don't collect their data in a standardized way, which would really make things move faster. It's a movement that the NIH is aware of, but a lot of these registries with observations made by professionals are funded by private companies or entrepreneurs or investment startups, and there isn't standardization there. So it's a problem inside mainstream science, as well as for some of the surveillance that might go on by citizens. The other big problem that I'm keenly aware of is a lot of the observations might be done by workers in factories, but then you get into some really interesting battles about liability. The asbestos plant or the cement factory doesn't necessarily want the union organizing surveillance of worker health or exposure levels if they're not going to fix it and, you know, get rid of the pollutants. The employers may be freaking out that they're going to find something in there in 10 plants that do X, Y, or Z. So I've seen that battled over that kind of, you know, we want to watch this, but it has major consequences.
Right. So we have two related questions dealing with funding. One's from Matthew DeFranco, and he asked, does money sometimes get in the way of research, which is, just the individuals with money, or, you know, will throw money into research before actually doing sufficient background research, maybe similar to the vaccine example Dr. Kaplan said. How does money factor into research in good ways and bad? And Maxime Polari asked similar questions. Beyond do-it-yourself vaccines, are you seeing other areas of citizen science in COVID-19 that you find worrisome? So I don't know, Professor Cooper, if you could talk about, you know, ways in which citizen science have been mobilized in COVID-19, not just vaccines, but in other ways, both positive and negative.
Well, there's, there was a program called Flew Near You that expanded for tracking COVID-19. So there's definitely been crowdsourcing efforts with the pandemic just for helping model the distribution and spread through simple apps where people report their symptoms daily, just prompted by that app to do it over and over again. So there's been some crowdsourcing efforts like that. And I guess I'll say just one thing related to funding, at least with citizen science, is that people often underestimate actually the costs of it. The costs of managing big data, the costs of managing volunteers, because people often think, oh, people are volunteering, so it's all free. But the infrastructure needed often for what is fairly big data and handling of it appropriately, and of making sure that sort of the benefits of the project are delivered back to the participants and beyond. All of that actually has a lot of costs with it.
And how is funding for citizen science? And I think this gets more at the heart of what Maxime's question was, because the question really dealt with whether priorities are being dictated by external funders who have their own priorities, perhaps even pursuit of profit over what we might think of as advancement of knowledge. So how do citizen science projects really get that sustainable funding going?
Yeah, that's the main special question, isn't it? So I don't know what has sustainable funding, but I mean, there are federal agencies that fund citizen science projects like EPA and NSF and NIH, and federal agencies that run their own projects. I mean, USGS has a lot of citizen science. For community science, there's an organization now that funds communities to partner with scientists to carry out research, but they put control of those funds in the hands of the community so that it will be sure to serve community interests. So, there's a few different funding models, I think, emerging. But I think it's an ongoing challenge, actually.
Well, since I'm the dreary participant in the citizen science discussion, let me point out there's also funding of involuntary community science or citizen science. If Facebook monitors all of us and starts to make inferences about what makes us happy or what makes us buy things, they're doing a kind of natural history of their consumers, presumably consented to by that 49-page waiver that they asked for. But nonetheless, it's a form of private funding of community-based science that drives a lot of people crazy, because they say, I didn't really sign up for that and I didn't understand that. The biggest example of this that drives me nuts is the Ancestry and 23andMe DNA collection stuff, where you send it off and they
Pay
tell
for
you
it.
whether you're Ethiopian or Welsh, but what they really want is your DNA.
Yeah, well, and I'm glad you brought that up because my hope actually for citizen science is that it raises people's awareness about the value of their information and about that they should have some control over how it gets used. And that so then efforts like that, or like having all the smart things that we have in our home that's collecting data. I mean, our homes are emitting tons of data that's going to companies. And to be able to have a say in that and to direct it towards, the way we might want our cities to be smart. Anyway, it's something that I hope really actually will come about through people being engaged in citizen science and seeing that model and asking for these other programs to be done in the fashion of citizen science where people have a say in things.
Great. So I think we have time for two more questions. One just came in, and it's a fun question, I think, for Dr. Kaplan. And it's from an anonymous attendee. What do you make of the possibility that the simplicity of CRISPR technology could lead to irresponsible genetic innovations by an individual citizen scientist or a group of citizen scientists?
Well, that's really where the hacking description comes up strongest for biology. And I do worry about it because it is not so hard to do CRISPR-based interventions. There's a lot of high school kids that have started to buy kits, and there are whole buildings rented out to do it yourself, if you will, biohackers trying to do synthetic biology. A lot of it you want to have done in containment so that nothing escapes. A lot of it, you also want to make sure you have some safety precautions in place for the people working around this stuff. And it's not really set up to do that right now. It's pretty Wild West. So it does concern me.
Professor Cooper?
Well, I can't answer that one.
No, okay, I just want to make sure to see if you had any thoughts. But the last one I think is a great one to end on. It comes from our head of programming, Kyle Roberts, Dr. Roberts. And he asks, are there lessons that citizen science can learn from community science or vice versa? And I don't know if you also want to just kind of reflect on these two different forms of kind of participatory science that we've talked about.
Yeah, I think that there's many lessons to be learned. I think the community sciences thing, especially like community-based participatory research, has very clear principles and guidelines that should be informing how we set up our citizen science projects. And actually, Raj Panja years ago, or like about 10 years ago, wrote about this. He drew on the principles from public health and community-based participatory research and similar approaches, and said what they might look like in ecology and in other areas of citizen science that are scaled large. And it's just hasn't really, a lot of that framework hasn't been implemented yet. I think one of the main principles is about the research agenda, is about having research agendas that are set by communities, as opposed to being set by like the whims of whatever is in fashion with academics or whatnot. So yeah, I think it's a good question. I think that, but the reason that they'll always remain somewhat different is because community science is local. And one of the powerful things about citizen science is that it can scale to hopefully still be relevant locally, but to really explore things at larger scales.
Thanks, Dr. Kaplan. Any thoughts?
No, I'm in agreement with that.
Great. Well, thank you all for kicking off what is going to be a great week-long discussion about citizen science. For those that are tuning in, our next session is at 3 o'clock this afternoon. It is our first panel on the promise of citizen science. And then every day after this at 1 o'clock, we'll have a panel discussion. And at 3 p.m., a showcase of a citizen science project. So I hope you all can tune in, and I look forward to seeing everybody online over the course of the next week for a great week-long conversation. Thanks again.
Thank
Thank
you.
you both.
Thank you.